This lesson concerns linear inequalities. We're going to look at the graphs of linear inequalities. Think back to when we were working with just number line inequalities and how we graph those with open dots, closed dots, and shading. And we're going to have a very similar parallel to these two-dimensional x and y graphs. So if you look at this sample here, this is the graph of y is greater than 2x minus 4. If you look at what some of the details are, notice that it has a dotted line because of the greater than inequality. That means that the dotted line means we're not going to include it in the answer, just like an open dot means we don't include it when we graphed on the number line. Also, on a number line, we shaded on one side or the other. Well, on these lines, we're going to shade above or below the line. We just have to decide which one. So let's walk through some steps for how we're going to graph these linear inequalities. First of all, you want to graph the boundary line. Now, when doing that, you're used to graphing lines, but you have to decide, is it dotted or is it solid? You'll know it's dotted when it's either a less than or a greater than. The ones that don't have the or equal to don't include the boundary line, so you would put a dotted line for that. It would be a solid line if it's a less than or equal to or a greater than or equal to, because those will include the boundary line in the solution. Every ordered pair on the boundary line is part of the answer to that inequality. Second, you're going to shade above or below the graph, above or below the line. So that boundary line, we're going to have an above side and a below side. You got to decide which one to shade on. The way you do that is by testing a point. You pick an ordered pair, like for instance, here's an ordered pair, 1, 2, and if I test that point, I put in 1 for x, and I put in 2 for y. Is 2 greater than 2 minus 4? And 2 is greater than 2 minus 4, because 2 minus 4 is negative 2. That's a true statement, so we're going to shade on that side. Every point over on this side, for instance, 4, 0, if we put that in, 4 for x, 0 for y, is 0 greater than 2 times 4, which is 8 minus 4? And the answer is no, that's false. 0 is not greater than 4, and so it would be a false statement. We don't shade on that side. So to shade above or below, you test a point. Test an ordered pair. If it's a true statement, shade on that side of the line. Now, you might say, well, that one's true, but how do you know the rest of them are true? Well, what's nice about these problems is if one of them's true on one side of the boundary line, all of them are true. If it's false on one side, all of the points on that side of the boundary line are false. So if it's false, shade on the other side. Okay, so false on this side, shade on the other side to do it. Now here is a tip for this, okay? So a tip is if 0, 0 is not on the boundary line. If it's on the boundary line, you can't use it. But if it's not on the boundary, use 0, 0. That ordered pair is usually the easiest to put in. 0 greater than 0 minus 4. That's true, 0 is greater than negative 4, so use 0, 0 if it is not on the boundary. Alright, now I need to remind you of one rule we have for inequalities. And so this rule is true back when you did just regular number line inequalities. It's true for these as well. We have one rule that will tell us when we flip over this inequality. When we're working with inequalities, you can always add to both sides of the inequality. You could subtract from both sides of the inequality. It won't change the direction of the inequality. But if you multiply or divide by a negative, it will flip the inequality over. If you multiply or divide by a positive, the inequality stays the same. Like if I were to multiply this by 2 and that by 2, stays the same. But if I multiply both sides by -1, it's going to flip it over. So this is just a reminder, and we'll put this in a box, a rule for inequalities. When you multiply or divide by a negative, you flip the inequality. Now remember, it has to be by a negative. If you multiply or divide by a positive, it leaves it alone. If you multiply or divide by a negative, then you flip the inequality symbol. Put that in a box just as a reminder that that's something that we have to follow for rules for inequalities. All right, let's go ahead now and try some examples. Let's work through these. Each example won't take too long, but make sure you focus on understanding how each one works. Remember, the first step is to graph the boundary line, but we want to know whether it's dotted or solid. This one does not have an or equal to, so I'm going to put down that this is going to be a dotted number line for us, or a boundary line. So we're going to start at -5, our y-intercept. So we start down here at -5, 1, 2, 3, 4, 5. And then I'm going to go up 2 and over 3. 1, 2, over 1, 2, 3. Up 1, 2, over 1, 2, 3. And draw a dotted line in, connecting those. Make sure it's very clear that it's dotted, it's not solid. You want to leave gaps in between several of the points. Now we want to test a point to see if that point works or not. So I'm going to test 0, 0, because 0, 0 is clearly not on the boundary. So this point right here, if we put in 0 for y and 0 for x, is this a true statement? Is 0 less than 0 minus 5 is -5? Is 0 less than -5? The answer is that's false. So don't shade on the side of 0, 0. Instead, shade on the other side. This is how we'll oftentimes do our shading, is just with some lines showing that we're shaded down below. Let's try the next one. What I want to do on this one is get it into slope-intercept form first. So I'm going to subtract x from both sides. Subtracting does not reverse my inequality. I'm going to put the x first when I subtract x from both sides, so keep the +4 at the end. Now I'm going to divide everything by -2 in order to get rid of it in front of the y. So I divide that by -2 and I get y. My inequality is going to flip over. Notice that because I divided by a negative, it flipped. So I'm going to put a little flip here to show that it flipped over. Now I'm going to divide this by -2, so that will give me a 1/2. -1 divided by -2, negative over negative is a positive, gives me 1/2. 4 divided by -2 is a -2. So now I'm going to graph this one, start at -2 here. I'm going to go up 1 over 2, up 1 over 2. And I'm going to draw, notice this will be a solid line, solid graph. So I'm going to draw a solid graph here through that. Now we got to test to see, is this going to be shaded above it or below it? So let's test 0, 0. And I prefer going back to the original instead of in this one. You could do it in this one, but I'm going to go back to the original. Is 0 minus 2 times 0 less than or equal to 4? Is 0 minus 2 times 0, 0, so it's 0 minus 0 is 0. Is 0 less than or equal to 4? That's a true statement. So since it's true, I'm going to shade on the side that 0, 0 comes, because all the other points are going to be true as well. Now this one's a little different. First of all, let's just be reminded this can be a dotted graph. You have to remember what x equals 4 is as a boundary, what that graph looks like. You're going to see these a lot in the problems coming up, so make sure you recognize that x equals a number, that's a vertical line. So remember that whenever you have x equals a number, you're going to draw a vertical line. Y equals a number is a horizontal line. So let's write that here. Y equals a number is a horizontal line. So just a reminder of some of our, when you don't have an x involved, excuse me, if you don't necessarily have a second variable involved, x equals a number is vertical, y equals a number is horizontal. So this is going to be a vertical dotted line at 4. Here's 4, right? So a vertical line dotted right there. And now we have to decide which side of that we're going to shade. Well, I'm going to test 0, 0 here. Notice that 0, 0 is to the left of it in this case. Now all I have to do is put in 0 for x, because there is no y in it. Is 0 greater than 4? The answer is that's false. So I'm not going to shade on the side of 0, 0. I'm going to shade on the other side, on the right side instead of the left. So looking at these examples, remember to follow the steps. When you're doing a linear inequality, decide on the boundary line. Is it going to be dotted or solid? And then graph it. Then test a point, usually 0, 0, to see if it's a true statement or a false statement in that inequality. If it's true, shade on the side that that point is. If it's false, then shade on the other side. If you don't want to pick 0, 0, you can pick any point, just remembering if it produces a true statement, shade on that side. If it produces a false statement, shade on the other side.